For this problem, we are going to find the total resistance. There's 24 volts, 15 ohms in the first resistor, 5 ohms in the second resistor, and 30 ohms in the third resistor.
Definitions. Circuit. A path between two or more points along which an electrical current can be carried. Resistance. A measure of how the flow of electric current is opposed or resisted. Resistor. Represents a given amount of resistance in a circuit, measured in ohms. Ohms. A unit of electrical resistance. The symbol is
Parallel circuit. A closed circuit in which the current divides into two or more paths before recombining to complete the circuit.
Series circuit. A closed circuit in which the current follows one path. Combination circuit. A circuit that is a blend of series paths and parallel paths.
Formulas. Parallel circuits. To find the total voltage, it will all equal the same. To find the total current, you have to add the first current plus the second current plus the third current. To find the total resistance, you have to put 1 over the first resistance, add it to 1 over the second resistance, and add that to 1 over the third resistance, and so on. Then take the inverse. For a series circuit, the total voltage will equal voltage 1 plus voltage 2 plus voltage 3, and so on. For the total current, it will all equal the same, and for the total resistance, you have to add the first current plus the first resistor plus the second resistor plus the third resistor. To find the voltage, you have to multiply the current times the resistor. To find the current, you have to divide the voltage by the resistor, and to find the resistor, you have to divide the voltage by the current.
Step 1. To find the total resistance first, we're going to redraw the circuit. When you redraw the circuit, you see you have two resistors in the same series, which are the 5 ohm resistor and the 15 ohm resistor. Then you see that those two are in parallel circuit with the 30 ohm resistor.
The next step is to add the two resistors in series up with each other. Since they are in series, we can easily add the 5 plus 15, which is 20.
For the third step, now the resistors are in parallel, so you can add them up in parallel. 1 over 20 plus 1 over 30, and you find the inverse. First, you have to find the common denominator, which is 60. So you multiply the 20 by 3 and the 1 by 3, and you get 3 over 60. Then you multiply the 1 over 30 by 2, so you get 2 over 60, and then you add those together, you get 5 over 60, and you take the inverse, and that gives you 12.
The 12 is your final solution because of breaking the series down, then reducing it from the parallel, and now you get your final solution.